The first part of the lab wants you to get 40 milliliters of water and place 40 milliliters of water into a graduated cylinder. So here's your graduated cylinder, and I have the bottom of the meniscus as close as possible, as precisely as possible at 40 milliliters. And so if you wanted to zoom in, you could see that right now that bottom of the meniscus is just hitting the 40 milliliter mark. I'm in units of milliliters. And what I need to do is I need to make sure that I have 40 milliliters of water available. I have an identical graduated cylinder that now I need to take the mass of the graduated cylinder. But the mass is not just of the empty graduated cylinder, it's the graduated cylinder plus the water. So I'm going to use my mass of the graduated cylinder plus the water, but just to make sure that I have my data, I want to go ahead and take this empty one, and we're going to say it's going to be really similar in mass. Might be a slight difference, so the sig figs is going to be okay. I'm going to take my digital scale. I want to make sure that I zero the scale. And so the mass of just the graduated cylinder alone, no water, is 69.39 grams. So to begin with, I have, well, now it just went to 69.38. So we're going to say 69.38 grams. We're going to give it a moment. There we go. We're going to stick with 69.39. So 69.39 grams is the mass of the empty graduated cylinder alone. I know it says 8, but it keeps switching back and forth. So we're going to say 69.39 grams. That's just the empty graduated cylinder. What we're going to do now is take the graduated cylinder, same kind of graduated cylinder. So the sig figs might be a little bit off if you were to take the empty mass of the two, but for right now, for our lab, this is okay. And I want to hit tare. I want to zero. And the mass of the graduated cylinder plus the 40 milliliters of water is now 108.39 grams. We'll give it a moment to just let it go back and forth until it figures out where it wants to be. And so this is now my mass of the graduated cylinder plus the water. My next step would be to take pennies from 1982 or later. So clearly I have a lot of pennies available here. From 1982 or later, and record the mass of the entire proportion, meaning the mass of the pennies inside the graduated cylinder plus the water. And that's going to help me also figure out the volume, the displacement of it. And so I want to make sure that you have all the data possible. So what I'm going to do right now is, before I actually begin the process of the lab, I'm going to take the pennies that are 1982 and later. So this penny is from 2015, but I have some from 1982 and some from maybe the 1990s. And I have a total of 12 pennies. So 12 pennies from 1982 and later. And I'm going to take the mass of the 12 pennies so that you have that as data. So 12 pennies from 1982 or later is 30.15 grams. That's your mass for just the pennies alone. If I now took the pennies from 1981 and before, 1981 and before, so those are also 12 pennies, the mass of those 12 pennies is now 37.00 grams. So we've gone through a couple of things. We've gone through the mass of the graduated cylinder alone, the mass of the graduated cylinder plus 40 milliliters of water, the mass of pennies from 1982 and later, and mass of pennies from 1982 and before.